Hello everyone, my topic is facade system. How can Ladybug be applied to achieve a more environmental friendly and comfortable architecture by optimizing the facade? As regards to the research background, an optimized facade system will include an analysis of the site's weather and the surrounding environment, identify the user community, improving the architectural material and the construction performance. In this way, the environment analysis tools could be used in early stages and the test stages. They also influence the performance of designing and the construction, so visualization of a system also can extend the long life cycle, crucial to sustainable development. Then my research question is, how can environment analysis tools be applied? Which tools could be used in the digital architecture industry? After research, I decided to use Ladybug because Ladybug could import the energy plugs weather files, providing the sun pace, radiation maps to visualize the manipulation. Ladybug also be able to combine with other environmental plugins such as Honeybee to conduct the daylight. The objectives for this project are an automatic facade system including the environment, analyze, test, temperature, daylight, design aesthetic and logic facade and the facade connections, test the connectivities and the construction feasibility, construct the traditional architectures with parametric facade architectures, extend the long life cycle of the architecture, achieve the comfortable and sustainable building. The mentions of this project including 3 steps: the Python and the Grasshopper and the Ladybug and Honeybee. This is the first time diagram, including the analyze, model and test, system and output. This slide is the whole workflow for this project, including the environment analysis, test facade design and retest facade, simulation system and the heat preservation system, in the end output an automatic facade system. The features of this project cover the automatic environmental fire extraction, gradient facade design, prefabricated construction of connections, automatic temperature and the daylight test, contrast the comfortable degree between the traditional architectures and the parametric facade architectures, construct the comfortable degree between the square architecture and the irregular architectures, automatic and visualized facade system. The other shapes in this model, which means surrounding architectures, because in the real life, the surrounding architectures also influence the daylight and the temperature. Here is the Grasshopper script for this project. The first stage is the environmental analysis, so I combine the Python and the Ladybug to output the initial environmental and the weather analysis. As architects input the nation name and the place name, Ladybug will output the sun pace to helping architects find the positive space for facades because this architecture is located in Sydney. The sun is setting in the north, so the north is the positive side. The architects should adjust the directions of models. By the reason of too many Grasshopper scripts for the facade design, so I cannot take screenshots and insert all of them. So I just shows the finished facade design. This facade including a square architecture and an irregular architecture. They both use the gradient facade in the positive sides. I scaled down the pattern and increased the number of patterns from the ground to the roof. This design helped me to observe and test results and construct with traditional and no-gradient facade. This slide is the detail of the facade and the connections design. For the connections of facade, I was considered a sandwich manufacturing process. These connections also take the benefits of prefabricated construction and the maintenance. From the photo, it shows the 4 steps, including the foundation and the connections, and the facade and the connection cap. Then, for the retest result of square architecture in January, the ladybug tests the comfortable degree of the whole facade, the traditional architecture, which means no facade architecture. The yellow color is the comfortable temperature for the residents. According to the data, the percent of time comfortable for the parametric facade architecture is around 76, but the traditional facade architecture is 55. In addition, parametric facade also could improve the two cold situations. For the test result of the irregular architecture, the comfortable degree of parametric facade architecture is 88%. The traditional architecture is 67%, and they also improve the two cold and the two hot situations. According to this analysis, it is obvious that the parametric facade improved the comfortable degree. I also calculated the difference of the comfortable degree, two hot and two cold situations. For the square architecture, the parametric facade contributed to the percent of time for comfortable and two cold temperatures. However, the percent of time for two hot higher than traditional square architecture. With the help of Honeybee, I detect the parametric facade also enhance the daylight, so I output the difference of daylight. In conclusion, after the initial environmental analysis, the designer should select the building directions manually. The gradient facade could improve the user comfortable degree. The irregular parametric architecture is higher than the square one. The parametric facade have had persuasion effects, reduce the time of two codes. For the square architecture, the parametric facade is ineffective in extremely hot weather. The daylight of the irregular parametric architecture is greater than square one. Improvement of daylight and heat preservation systems of the external wall is benefits of energy reduction. Achieve the sustainable development. The simulation system of facade system helping architects observe and adjust their projects more intuitively. In the future, for the square architecture, improve the facade design to adapt to hot weather. Explore when the data of the comfortable degree changes, what is the relationship between the comfortable degree and the heat preservation degree. Combine with the Python, make this automatic facade system as a grasshopper or Revit plugin. Explore applicable material to extend the duration of the architectures to achieve the sustainable architectures in the future.